Dr. Steve Holen. Welcome to Underground.
Good morning. Nice to be here.
It's a pleasure to have you. Underground features independently minded archaeologists, anthropologists, historians, and science renegades on controversial topics and themes. And among those controversial topics, the peopling of the New World seems to be an audience favorite. And you, my friend, have a fascinating story to tell on that subject. So I'm very excited to have you here. For our audience's edification, Steve has a PhD in anthropology from the University of Kansas, and you currently reside in Kansas. You're the managing director at the Center for American Paleolithic Research, a nonprofit organization located in Hot Springs, South Dakota, that is dedicated to researching the earliest presence in the Americas. Your nonprofit's journal is called the American Paleolithic. You've done a lot of different things in your career. You did cultural resource management for the better part of 30 years, and you worked for the University of Nebraska, the Nebraska Highway Authority. You're the museum director at the Dawson County Museum. You worked at the University of Nebraska State Museum, and you were the curator of archaeology at the Denver Museum of Nature and Science, which is the fourth largest natural history museum in the nation, which is amazing. You're currently an adjunct at the Sternberg Museum of Natural History and a research associate at the San Diego Natural History Museum. You're very well published, including what one might argue a seminal article in Nature. So congratulations to you on that. And you are known for a lot of your work, but certainly for your work on the Cerruti Mastodon site in California, which one might argue is the earliest documented case of activity as a result of the genus Homo in the Western Hemisphere. So that's amazing. I'll say that in more layman's terms. That is the earliest human site in the Western Hemisphere. I think that's safe to say. So it's a pleasure to have you. What did I miss in your bio?
I think you hit it pretty well. Actually, our center is now in Topeka, Kansas. Probably didn't get something updated on the webpage. So.
Yeah. Okay, good to know. Topeka, Kansas.
Yeah.
Where are you originally from?
I'm originally from a farm in the central Platte River Valley in Nebraska. So I grew up on a farm. I went to a rural school. I walked home and collected rocks on the way home from the gravel on the gravel roads. I was born to collect things and find things. So I then discovered that there were when I was about 11 years old, I discovered there were archaeological sites on land that we farmed. And I liked to pick up artifacts a lot, much to the chagrin of my father, who thought I should spend more time farming and less time picking up artifacts. So I also grew up, our relatives ran gravel pits along the Platte River, and they would find mammoth teeth all of the time. So I grew up with a mammoth tooth for a doorstop in the house. And I was always fascinated by something that had teeth that big. And so when I later got to the University of Nebraska State Museum and the Denver Museum of what it was called Denver Museum of Natural History then, and saw complete mammoth skeletons on exhibit, I always knew that I wanted to study mammoths. So I kind of was born this way, I guess you'd say.
That's what we see a lot with our guests. It seems to be in the blood. It's a calling from the earliest of ages. The peopling of the New World topic. Have you always been interested in? I mean, you're talking about mammoth, mastodon. That would push you back into the Pleistocene. Has that always been kind of the period of fascination for you?
Yes. In my undergraduate work, I was trying to resolve the question of the Angus mammoth that had been found back in the early 1930s in Nebraska with an associated artifact with it. So I began my research in 1971 on that. And it took many years to finally figure out the answer to that problem and didn't get it published till about 2010. But anyway.
That's a few years.
Many years. Well, they got new dating techniques, and we were able to date the mammoth at much older than Clovis. And there wasn't really any indication that there was human association with it. It's almost certain that the artifact was planted with the mammoth to make it more valuable in trade, so to speak. So
I see.
I'm just I'm just as interested in disproving things as I am in proving things. So yeah.
Interesting.
Yeah.
Well, it certainly is important. I mean, that's, you can't approach these kinds of problems with bias. I mean, you have to be open minded to it being legitimate and illegitimate as well. So that's good to know. Well, look, we have a lot to get into. You have such an interesting research background and great perspective. So I kind of want to dive into the Cerruti Mastodon site, which again, having reviewed your research in preparation for this interview, I'm really compelled by it. It's impressive, exhaustive research. So well done. But let's get into the basics. Where is, tell us how you learned about Ceruti, how it was discovered, where it is, by whom, and what you did there.
Well, the Cerruti site was discovered on a paleontological project on Highway 54 in southern San Diego, and they were monitoring this highway construction and salvaging paleontological specimens. And Richard Ceruti was the main gentleman monitoring this, and a backhoe hit mastodon bones, but they also hit large cobbles. Well, Mr. Ceruti is an excellent flint knapper, and he's also worked extensively with archaeologists. And he realized that these broken mastodon bones being situated around large cobbles was probably important because the geological situation was very fine-grained sediments. So he knew that these big rocks couldn't have been deposited there in a flood. And so he convinced his boss, who is actually Tom Demery, a whale paleontologist, to excavate this site like an archaeological site. So Mr. Cerruti and his background knowledge in archaeology saved this site for science. And so they excavated this site in the early 1990s. They tried to get some archaeologists involved, but the archaeologists knew it was so old that they weren't interested. It could not be an archaeological site. It was too old. And that's what we keep running into throughout the history of these studies of early humans in North America. So people find things, especially paleontologists, and the archaeologists say, well, that's too old. It can't be. So things get lost. Yeah. So that's how it was found in the early 1990s. I first found out about it from a colleague of mine, Rob Bonnickson, who is the director of the Center for the Study of the First Americans. He told me about it in the mid 1990s. He had actually visited the collection and said, Steve, I think this is a really old archaeological site. And so at that time, I didn't have the time or resources. I was doing cultural resource management and just didn't have the time or resources to go visit it. But then later on, I read a reference to this, what they called the National City Mastodon site then. And I was with the Denver Museum and I had time and resources. So my wife and I flew out to look at the collection of the Cerruti Mastodon site. And I walked in, saw the thick calcium carbonate concretions on the bones and the rocks, and realized that this site probably was over 100,000 years old based on that type of deposition of calcium carbonate. And so basically, Kathy and I were trying to decide what we should do about this now because we knew it would be so controversial, but it was evident that it was an archaeological site based on all kinds of different criteria: the impact fractured bones, the large rocks in fine-grained sediments, and we could see some wear patterns on the rocks and so forth. In fact, that evening at dinner, my wife saw me staring off into space, and she said, "What's wrong with you?" And I said, "This goes against everything I've ever thought I knew and everything that I've been taught. How can this be? And what are we going to do about this?" So I was in kind of a state of shock when we first visited this collection, but we decided that this is science and we're scientists and this is what we do. So we started to work with the paleontologists, and it actually took 10 years of getting a team together and doing the research and finding the funding and so forth, and then trying to get it published in a major journal. So yep, it was quite a long experience.
Was the entire site excavated by Ceruti in the early 90s?
No, actually, we've talked about going back into the site. We think there's more of the site left. They excavated a significant part of it, but I'm pretty sure there's still a little bit left.
Yeah. So let's talk about the site itself, because it's interesting. Of course, most folks thinking you're talking about an archaeological site, you're going to see obvious artifacts with hopefully diagnostic characteristics, and you can identify it with a particular culture group, etc. But this is a little different. Tell us about, you're talking about bone and cobbles. How are they arranged, and what is it about the arrangement that suggests to you humans were involved?
Well, I think if we could go to a slide here, I would like to maybe show
Sure.
slide number 15.
Okay.
Let's,
All right, we got it.
oh, no, go on down further. I'm sorry. I'm looking at it. It's a bone bed map.
The bow bed. Okay. No, this right here.
Yes.
Okay.
So if you look at the color coding there, the mastodon bones are in blue, the rocks are in red and green, and then the molars and tusks are in orange. So you can see the distribution there, and especially if you look kind of in the center of this, you see a lot of bones right around a big red rock there, and some other uh, pieces of red rock. So can we go on to another one of these
Sure.
slides?
Which one do you want?
This one. Oh no, the one, the bone, yeah, this one. So what we noticed was that almost all of the bones are broken, and they're broken while they're very fresh. They have what we call green bone fractures, but there are bones that are complete, and the circles around there on the left, those are some vertebra and some ribs that are complete. But there's also a heavily broken bone right with them that has a big impact notch on it. And if you look around, the only other complete bones there are a couple of ribs and a tusk. All of the big limb bones that are the thickest, strongest bones, the femurs, are broken all to pieces. And where they're broken, they're concentrated right around these green rocks that we interpret as anvils. And if there's another slide down lower that shows some of the refits, if you could go to that. Uh, Another bone bed map.
The refits. Is it? Can you describe what it looks like?
It'll have a lot of arrows going back and forth between the bones.
Oh, it's a okay. Another bone bed map. Got it.
So here we have the two concentrations of bone, and then down to the next one. So these are refits of different. This is just showing where the hammerstones are and the anvils point, the arrows pointing to them, and then go down to one where we show refits with arrows going between bones. Okay, here. That's a good one right there. So
Okay.
here we see refits of a molar near two different near two different anvils, and then go up one. Oh, go up two more there. So this is a large granite hammerstone, and you can see where it refits with pieces right around what we interpret as the anvil. So this big rock got broken, and we did an experiment in which a friend of mine made a granite hammer for me, and we hafted it on a handle. And the first blow, when we struck the bone that was sitting on an anvil, it slipped off and hit our hammer slipped off and hit the anvil and broke all to pieces. So I know what this person said when they hit the anvil and broke their big hammerstone, because I said that was $100 down in one blow. So
no.
so that's what we've got. We've got refits of these different rocks. We also have refits of bones, and the activity areas around those anvils have all of the broken bone, the spirally fractured bone, and pieces of the hammerstone where it hit the anvil and broke. So this is what we do in archaeology. We do refits to determine what happened at the site. And at this site, they broke at least two femurs and they broke a molar, and the pieces that are left are concentrated around, and the pieces they wanted they would take with them, and they wouldn't be there at the site anymore.
So let me see if I've got this correct. there were two anvils. So for folks listening, these are large stones, possibly with a flat surface, that are the base. Those go down first. They're sitting on the earth. The individuals who broke the bones would take the femurs. You said there were a couple of femurs broken,
Right.
and they put the head of the femur or thereabouts on the anvil, and then with the hammer stones, maybe somebody's holding the femur in place and another individual is crashing down the hammer stone onto the bone over the anvil, in an attempt to break it open to extract the marrow.
Right. And that's what we did. And we've done experiments to recreate this type of breakage. And maybe this would be the time to show one of those. If you would.
Yeah. All right. Let me pull up this video. We'll do the one from your now. As I'm pulling this up, this is a video of you doing this in Africa. Why don't you tell me a little bit about why you did this experiment in Africa as I cue it up?
Well, it's much easier to get elephant bone in Africa than it is here. Here you have to get it from zoos, and the elephants live to be a long time, and they're hard to find in the United States. So we went on an archaeological expedition in Tanzania, Africa, and we're in Maasai country. As you can see, the gentlemen on the left are Maasai people. And we found a dead mammoth, and they allowed us to cut one femur out. So we actually made an anvil of wood here, and then hafted the large rock onto a 4-foot long handle, about a 10-pound rock. And so I'm going to try to break this. And if you'll show a couple hits with that.
Yeah, I want to point out, it's interesting that you fixed the hammer stone to a shaft,
Right.
which do you have any reason to believe, we'll show this in a second, but do you have any reason to believe that was also done at Cerutti, or are you improvising here?
No, at Cerutti, they use just big rocks. You can use a smaller rock, like this one's only about 10 pounds, on a long handle. If you don't do that, you have to use about a 30-pound rock, handheld rock. So that's what we did in our experiment.
All right, so let's see what happens. This is really cool experimental archaeology, by the way. So you're going for the head here, the joint basically, and not the shaft of the bone, the femur. Why is that, Steve?
Well, the bone is the thinnest up near the head of the shaft, and we thought it would be easiest to break it there. And that's why we do experimental archaeology. We were 100% wrong. So it's much more difficult to break the bone up near the head of the femur. And you can see I'm not having any success at all. And I soon give up. This young man is 21 years old. He's much bigger and stronger than I am. He's from Canada, a student studying archaeology. And so he's going to take a couple whacks at it. And even he has difficulty breaking it,
right?
The reason that this is difficult to break up near the head is there's this spongy bone inside right there that's very thick, and it acts like a shock absorber. And it's much more difficult to break it there than it is at mid-shaft.
So that suggests that the individuals who broke the mastodon at Cerutti were willing to make an additional effort to... there you go.
Yeah, finally. That's the 10th hit, by the way.
Okay.
And I think if you want to see, then we set it up a little further, and I break the bone at mid-shaft, and you can see how much easier it is to break it there when I was not able to break the bone up near the head of the femur.
Oh my God.
Yeah, it splinters.
Just one blow and it comes apart because the bone is thick and it breaks in a spiral fracture very easily. There's not much spongy material inside the bone at the mid-shaft. This just shows me flaking. You can flake bone like you can stone, not make real fine little points and things out of it, but you can make very good tools by flaking the elephant bone or mammoth bone or mastodon bone.
Do you see evidence of flaking the bone happening at Cerutti?
we only see evidence of impact at Cerutti, but at other sites that I've excavated, like the Sena mammoth site and the Lovewell mammoth site, we see evidence of them actually taking the bone and flaking it and making tools out of it.
Okay, so if you've already answered this question, I apologize. I'm going to ask again. They're going for the head. What is there a concentration of marrow in the joint? Why would they go to that additional effort, expend those additional calories to break the most difficult part of the bone?
This spongy bone contains a lot of oil, and so that's one reason you can get marrow and oil out of the bone, and that's very high energy food. And hominins have been extracting this marrow from bones for at least 2.5 million years ago, based on evidence from Africa. It's a nutrient source that other animals didn't really have access to because they couldn't break into the middle of these bones.
Yeah. Okay. Well, that makes a lot of sense, and it's consistent then with what you're saying. You're seeing in other Paleolithic sites around the world. Where else are we seeing evidence for that extraction?
We see it beginning all over the world, beginning about 2.5 million years ago. Everywhere where people were hunting large game, you see marrow extraction. Neanderthals have an extensive evidence for that. In fact, there's just a new publication. They have a site where they think they were, it was kind of a specialized marrow extraction site, and they think they may have been even storing some of this fat for winter use. So anywhere where you see hunters hunting large game, they're extracting the marrow from the limb bones.
Amazing. It's interesting you said Neanderthals. We'll come back to that. In order to keep things rolling along, as I discussed, I have a million questions, but because you have so much to offer here, we'll have to hustle a bit on it. But I want to say to the folks listening that, read Steve's paper, look at the way the site, the artifacts, the bone are distributed across the site. And to me, it looks fairly, it looks like an obvious butcher site. I mean, this isn't some exceptional in terms of the characteristic of the site, way outside the realm of these kinds of sites. It really fits beautifully right in. You can almost rewind the activity as it's playing out, as you did through the rebuilding of the Hammerstone, et cetera, et cetera. To me, it's obviously an archaeological site. So the question falls to the dates, and you've proposed a date of 130,000 years. Talk a little bit about how you got the dates and how confident you are in the dates.
So I had to do a lot of learning of new dating techniques. When you get beyond radiocarbon will only go back to 45 or 50,000 years old. We tried to radiocarbon date the site, and there was no collagen left in the bones to do that. We then tried to use OSL, optical stimulated luminescence, to date the sediments themselves, and we only got minimum ages of about 75 to 80,000 years there. And I'm not going to go into the complex of that, but so they couldn't date any older than that, but they knew the site was older than that. So then many years ago, I had taken a course in dating and archaeology, and they talked about uranium series dating, and they've really come a long way in the last 20 years on uranium series dating. So we contacted the United States Geological Survey, and Jim Pacey's is an expert at that dating in Denver, and he agreed to date the site for us, and he used cutting edge technology where you date it's sort of like radiocarbon in the sense that you are dating the decay of radioactive materials. And so he did a lot of testing to make sure the bone was suitable for this type of dating, and came up with dates of 131,000 years plus or minus 9,000 years. And the reason we know this dating is good, one of the reviewers on the Nature paper uh, was a uranium series, one of the leading uranium series dating experts in the world, and he said, "This is cutting edge technology. This is how old the site is." So we're very confident in the dates.
For the audience and myself as well, there's was there any organic material left in these bones? Because uranium obviously is not carbon, so you're dating something other than remnant organics, correct?
Right. Uranium is taken into the bones from the surrounding soil and water. Um, so it goes into the bone. Uh, and so then you date how much of the uranium has broken down since since the uranium was deposited in the bone. So it has a half life, and so it's like radiocarbon in that sense. The decay of radioactive material can be dated.
And there's something about its intrusion into the bone that starts the decay clock,
Right.
presumably.
The problem, there is a problem with uranium series dating, and that is that water can leach the uranium back out of the bone once it's deposited in there. And the way he got around that problem was every 2 or 3 millimeters through the bone, he ran a date, and all the dates came back the same, which means the bone hadn't been leached, and therefore the dates would be bad. That's why he was able to get accurate dates on it. In some
Yeah.
situations, the uranium is leached back out of the bone, and you can't get an accurate date on it.
Okay.
It's very
Yeah,
complex.
that's terrific. Sorry, go
It's above my pay grade.
ahead. Mine too. Did you say that the margin of error was 9,000 years either direction?
Yes. Yeah.
Okay.
A little less than 10%. That's pretty good.
Yeah, no, I mean, and the site preservation is phenomenal too. We don't have to go too deep down this rabbit hole, but presumably it was floodwaters had deposited a fine grain sediment on it shortly after um, the butcher site was established.
Yes, there is actually a buried soil there. There had been a soil formed over quite a few years, and then kind of low grade flood deposit over what they call overbank deposits when the stream goes out of its bank and it deposits fine sand and silt. So there's no evidence of large scale flooding there. If there had been large scale flooding at the site, all of the small, tiny bone fragments and rock fragments would have washed downstream, but they're still setting right where they were left. So these small, light bone fragments are key indications that there hasn't been a major flood there. Just very slow energy, low overbank deposits um, covering the site with sand and silt.
Yeah, terrific circumstance that we're all very fortunate played out. 30,000, 130,000 years strikes me as particularly early here in the Western Hemisphere to have, well, certainly those kinds of dates with hominin activity. But you've worked on a bunch of Proboscidean, Mastodon, mammoth sites in the past. Is this the earliest of that, or are there other examples of relatively similar level of preservation with sites of that age or earlier?
This is the earliest one that I know about. There's another mammoth that unfortunately fell between the cracks of archaeology and paleontology that might be nearly this old, but we'll never know. It'll never know be sure because it never got excavated properly, and it was too old for the archaeologists, and the paleontologists didn't want to work on it, and it just ended up getting lost basically. So
Yeah, that
that's a sad story that's too common.
Yeah, well, let's get into that here in a bit. I want to ask you, you've talked about the flaking of the bone tools, which is interesting because obviously for people listening, we didn't find any flake lithics to speak of. So there weren't any lithic tools besides, of course, the hammer and the anvil. Um, but you did see evidence for them flaking the bone. So this was a culture group that used uh, bone tool technology, presumably, which might explain why it's not particularly well preserved throughout the Western Hemisphere. But on that note, are there other places where in the world where we are aware of this treatment of bone for preparation of tools, um, in combination with hammer and anvil type crushing activity?
Well, bone is a very good material for making things like hand axes. So there's some sites around Rome that date to the Middle Paleolithic, 300,000 years or so. And in that area, there's not any large stone that's good for flint knapping. So they were making hand axes out of elephant bone there. And this is common. You've seen it at several sites in Europe. You see hand axes and other kinds of chopping tools going back at least 1.5 million years ago in Africa. So bone is a very, very acceptable material if you don't have good stone, or if you're right there butchering a mammoth or mastodon or elephant, you can make your tools right on the site. You can make these big chopping butchering tools if you get one limb bone out and flake it. So that's what we see happening a lot. These are oftentimes what we call expedient tools. You might not take them with you, but they're perfectly good tools for butchering the animal right there on the site.
Yeah.
In other cases, you want to, in the later Paleolithic sites, you take the bone and flake it down into a piece that you can transport, and then later on you can make highly sophisticated tools out of it, like shaft straighteners and projectile points and things like that when you have more time. Ground stone tools, ground bone tools, I mean.
What
So
about here in the New World? I mean, obviously, bone pins, bone, awls. There's bone tools that we see associated with lithic tool assemblages all over the place. But do we see any? Is there any evidence for, you know, purely bone-based tool assemblages?
I don't think there are just bone-based assemblages. I think the reason that we're seeing this in a lot of the sites that I've excavated in the Great Plains, what we're seeing is people are just harvesting the bone for marrow or pieces of bone to make bone tools out of. In fact, a lot of these, I think, are natural death sites. They're not kill sites. If they were kill sites, I think we would see stone butchering tools there. So I think what we're seeing, a lot of this is bone quarrying, just getting the bone to get the marrow out, or to get bone to make flake bone tools or ground bone tools. They're just a quarry site, and may not necessarily even use the meat from the site. In fact, the animal may have rotted, and the bone is still fresh enough that they can use it. So
Eh.
a lot of these sites that I've excavated are large male mammoths, and you probably don't hunt those. You probably would prefer to hunt the younger animals that wouldn't be such tough eating.
Yeah, a mammoth was certainly formidable. Mastodon as well, of course. The I saw that in your follow up to the Nature article, you had a supplemental, and there was a discussion of micro residues. I believe was in there. That's interesting, and I felt was quite compelling. Can you explain that a bit?
Well, when you use these rocks, the residue can preserve in it for a long time. So there was a team in Australia that took some of the rock and determined that there was residue from mastodons on the rock. So that's just one more piece of evidence that people were actually using these rocks to process the mastodon bone at the Ceruti site. So this was again published in a big time journal, and it's very good science, and it just backed up what we said. I'd like to also add that if you want to know more, we were only allowed about 15 or 1700 words in the Nature letter. There is a supplementary section of 72 pages if you want to learn a lot more about the Cerruti Mastodon site. So,
Yeah.
and it's available online.
Yeah, and I'll so that would be well, we'll talk a little bit about that, but that's your nonprofit website where folks can find that, and I'll give information on that here towards the end of the conversation. So I've already mentioned that I'm a fan of your work, and I think the research is really pretty rock solid. Of course, there are some arguments. There has to be alternatives that if somebody isn't accepting it as an authentic archaeological site, there I'm not seeing very many compelling arguments against it. There was somebody who was talking about the dump trucks and excavators associated with the road construction having crushed the bone and distributed the artifacts across the site as they were found. That seems highly questionable. But Address that, and what would you say is the strongest arguments against your hypothesis?
Well, yes, the person especially that talks about big equipment being on top of this site, and we have one picture of a huge backhoe sitting up on top of the berm, taking off the overburden over the site. But I worked around big equipment my whole life. I grew up on a farm running pretty big equipment. My relatives ran big equipment at gravel pits, and I've used big equipment on a lot of my excavations to get the overburden off. And I can assure you that you can have a bone 2 foot deep and run a caterpillar over it, and it won't break it because the tracks on the caterpillar are very wide, and they're made not to sink into the ground, and they're made so that they can work over utilities and pipes under the ground and so forth. So anyone who makes that statement really probably hasn't worked around big equipment very much. So uh, I've seen bone broken by big equipment, but it was in a sandy substrate, and the mammoth bone was only about a foot deep, and it got broken. But if you get any deeper than that, it would not break bone. So it's not going to break bone at 3 meters deep from any kind of.
Can't you tell? I think you also had mentioned in your paper that the breaks show signs of having been broken when the bone was green. These are not recent breaks.
These are not recent breaks. The bone was broken while it's still very fresh. It's easy to tell that by the spiral fractures going around the bone. The little impact notches when a hammerstone hits a bone, and there's a slide earlier up here that shows that. You get little flakes around the point of impact that are called impact flakes, and they're very distinctive, and they're only formed by hammerstone percussion. So we find those. We found them right around the anvil. We found them at all sites, and we've created them in our experimental work. So uh, that's more evidence that humans were breaking this bone.
Yeah. So that's a good segue. Humans were breaking this bone. We've talked about possible analog sites. You've mentioned the site in Rome, 300,000 years old. You've mentioned even earlier sites that go back to, potentially, who knows, Australopithecus or certainly Homo habilis, early sites in Africa. You've also mentioned in the conversation Neanderthal. Um, you know, Who do you think built? Who do you think is responsible for the Ceruti site?
Um, it's impossible to know, but we have to surmise. In fact, when we published the Nature letter, we tried to kind of stay away from that subject, and the reviewers insisted that we speculate. So the speculation is that it's not modern Homo sapiens. So that kind of leaves us with Neanderthals and Denisovans would be the most likely culprits in this situation. They were fairly far north in Siberia during the during the Middle Paleolithic period, and so they could have moved further north as it warmed, and the climate warmed rapidly around 130,000 years ago, and we think they moved north and moved into North America, and then some of them probably came in and went down east of the Rocky Mountains along the Great Plains, adapted to big game hunting. But we also think that people were adapted to using maritime resources and had boats and were moving along the coast probably at the same.
Sure. Well,
So that's our speculation.
I love it. You got to speculate, and that's where it gets fun. Denisovans were not even a whisper of a reality when I went and did my paleoanthropology classes at Santa Barbara many moons ago. So, for those of us who are not terribly familiar, I think a lot of us have a good sense of Homo erectus or even late or Neanderthal or late Homo erectus. Where did Denisovans fall into the mix? How do they compare to some of the other archaic Homo species?
Well, we now know just in the last few years, very few years, we know that Denisovans were all over Eastern Asia, uh, from areas down at high altitudes in Tibet, in Laos. Now they found one from the bottom of the ocean just off Taiwan, in northeast China and at Denisova Cave in southern Siberia. So they were adapted to a wide range of environments, hot, humid environments, high altitude environments, high latitude environments. They were a very adaptable species, and that's what's been so interesting about following the Denisovan research in the last few years. And some of it's just come out in the last few months. In fact, they just identified the skull from Manchuria, China, at Harbin as a Denisovan based on DNA they extracted from dental calculus.
So you're saying just again for the audience here, Deneth, pronounce, because I've always heard it being said Denisovan, but you have a different pronunciation.
Denisovan. Well, I've heard it both ways, Denisovan or Denisovan. I don't know which one is.
Denisovan. Okay.
Yeah.
I'll probably stick with Denisovan,
Okay.
so I don't butcher it. Well, that's very interesting. I mean, we're not expecting you to suggest the Denisovans. Now I've got myself in a tongue tie. I was thinking that you were going to suggest potentially either late Homo erectus or Neanderthal. Of course, Neanderthal did have a toolkit, lithic toolkit. They had, the Mousterian tools, and they used the Lavawa technique for stone tool manufacture, nice big blades, and so on. And we don't see any of that. I am not familiar at all with the lithic toolkit of the Denisovans. Did they have one? Presumably they did.
Yes, and in Denisova Cave, they've identified the lithic toolkit of Denisovans. And, it's a fairly typical flake technology and biface technology. So it's not unknown, and that's probably the best site where they've identified this. So, and there's quite a few publications on the cave there, and so I would direct readers to go to that literature.
Yeah. Do we see Denisovans in association with mammoth or mastodon butcher sites?
We in Denisova Cave, there are all of these step adapted species in the layers that have Denisovan tools in them. Also, at the high altitude cave in Tibet, we also have evidence of them hunting these large species of animals, not necessarily mammoths there, but other large animals like bison and so forth.
Okay, so they like the big dogs, so to speak. You mentioned the west coastal route. We know, of course, from evidence of in the Western Pacific, the Wallace Trench, people were going over open water stretches over 100,000 years ago. Crete, 130,000 years ago. Would you think that any sort of entry into North America would via the coast would have been done by an archaic Homo sapien, either Neanderthal or Denisovan, or are you kind of reserving that a little bit more for Homo sapien?
No, I think at 130,000 years ago there weren't any Homo sapiens that far into China that could have done this. So I think we're talking about an extinct form of Homo doing this 130,000 years ago, because these people that reached some of the islands in Southeast Asia, and we're finding sites really old on some of these islands. There's never been a land bridge. These were not modern Homo sapiens. They were Homo.
Yeah, you're right. Homo florensis, for example. I think they would have had to have used, certainly, to have gotten to Flores watercraft.
They must have had some kind of watercraft to get across that strait. There's this very strong current that flows through that strait, and people say, well, they just drifted across on organic mats. Well, you have to get a whole breeding population across, and there's a very strong current there that would take you out to sea rather than get you across to across to Flores Island. So I think they must have had some pretty good watercraft early on to get to these islands where there's never been a land bridge.
That would have been something to see. An army of what do they call them? The hobbits making watercraft to sail about in the Southeast Asia. You've talked about potential candidates for the Ceruti site. You've said, possibly Neanderthal, maybe probably not an early Homo sapien because of the fact they weren't far north enough to have come over the Beringia, the land bridge, possibly the Denisovans. I know that in South America, there's some interesting genetic data and cranial data that suggests potentially an Austronesian population had made it into the Western Hemisphere at a very early period in time. Though that population would be, as far as I understand, Homo sapien. Are you aware of those theories, and do you have any opinions? And do you think in any way that they could be responsible?
Yes, it's very interesting to find this genetic signature of a population Y in these remote tribes in South America that are related to Australasians. And but the interesting thing is there's no modern population over there that fits this genetic signature. So therefore, it must be really old and has changed since then. And so the authors state that there must have been at least 2 migrations into North America, one quite early. They don't put a time frame on it, but based on that genetic evidence, and then there's a couple of other articles published more recently that kind of support this, that there was a group that got in. At least they say it must be quite ancient. So we don't know how much that is, but my guess is they're thinking probably maybe 30, 40,000 years ago. But I would suggest maybe we're seeing the signature of the people that got in. Uh, part of this population Y signature is Denisovan. So it's possible that that's what we're seeing is a remnant of a really early population that got into North America, made it all the way down to South America. And this might suggest evidence for a coastal migration.
Wow. Oh, that's fascinating. Well, I don't know this South American research particularly well. I will be interviewing somebody on this topic before the end of the year. But is this genetic data? It's not coming from any living or recently deceased populations, correct? We're not talking about Fuegians here. We're talking about genetic material that's come from human remains that are many millennia old, correct?
No, not correct. There are living populations in remote areas in Brazil that have this genetic signature still.
Wow. All right.
Yeah.
So,
and then they've gone back and tested some skeletal material in different countries in Central and South America and have found some of the same genetic signatures. And they've even found some that's more Denisovan than it is population Y. So it's and I'm not a geneticist, so I read the literature at kind of the National Geographic level. But anyway, it's very interesting, and it's very supportive of an early migration. And to tell you quite honestly, the archaeological evidence for early humans in the Americas is much better in South America than it is in North America.
Yeah. Yeah. I've heard that before, and we're going to start getting into the South American material because of that. I think it's a whole new book to open up here for establishment archaeologists of North America to learn a bit more of what's going on down there. But that's fascinating. I want to revisit that just to kind of succinctly put it. The argument is being made that there are indigenous populations in South America that carry a gene that may have come over with Denisovans over 100,000 years ago.
That's my speculation, and none of the other authors that are publishing this have suggested that. So
okay,
that's only my speculation. So
I love it. Well, you've talked about a couple of different ways in which people would have come here, coastal routes. You talked about this interior route following the steppe, and you've written a very interesting paper and proposed what is the mammoth steppe hypothesis. And just to be clear, that is your theory, correct? This is you and your team have developed this theory independently, correct?
We thought we had, yes. And then when you develop your theories and you go into the literature further, and you go back, and a man in Germany had suggested pretty much the same theory back in about 1967. So his name is
Yeah.
Hans Jürgen Mullerbeck, and so we thought we were pretty smart. We'd come up with this new theory and it would look real good, and then I ran into his work and I went, "Oh, he thought of this a long time ago." So, and he didn't have
Hey,
nearly as much data as we did. So, but his
yeah.
article was very forward thinking.
Um, obviously. Well, why don't you describe what is the mammoth step hypothesis?
Well, it is that modern Homo sapiens, and when we developed this, we didn't really know about the Ceruti site yet. And I didn't think it was possible that humans got into North America more than 130,000 years ago. So we thought that this was the initial occupation of the Americas, that modern Homo sapiens were able to move north in Siberia and during the mid Wisconsin, and there were some warmer periods there, and there was a land bridge much of the time during mid Wisconsin, that they were able to uh, become adapted to what we call the mammoth steppe. That's this biome of animals adapted to this vast grassland. And mammoths, mammoths, bison, horses, so forth. That were in Siberia, and that humans were able to cross the Bering Land Bridge and make it down into central North America in the Great Plains, where I was excavating these sites. So that's in general humans becoming adapted to living in the open plains and adapted to hunting this large game. And once again, we we thought these were the earliest people, modern Homo sapiens, coming into North America, and thought that anybody suggesting humans were here 100,000 years ago were quite fanciful. So
Well, these are still some early entry points here. You're talking about people coming in 30 to 40,000 years ago. I mean, that's uh, certainly well pre-Clovis. Well, it is pre-Clovis. Uh, what evidence do you have to support that early presence?
well, once again, we're using fractured mammoth bones in this situation, and we've excavated several sites in the Great Plains. The first one was the Sena mammoth site, and if we could show a slide of that, we can
Sure.
start just talk a little bit about this. This site was found in wind-blown lust, very fine-grained lust that was blown in to this area over a 10,000-year period. And a Bureau of Reclamation archaeologist found mammoth bone on the beach and looked up and saw mammoth bone coming out of this cut bank about 3.5 meters deep. And he contacted me, and we came back in and brought a backhoe and dug down to just above the mammoth bone level, and then used shovels to get down a little closer. So this is a shot of our second year of excavation there. You can see what we were up against. But
Amazing. What year was this?
this photo would have been taken in 1990.
1990.
We
Yeah, I
worked.
think OSHA was less engaged in archaeological work back in those days.
Um, well, the Bureau of Reclamation archaeologist who was kind of overseeing this project actually took a picture of this the next that later that year back into his office, and their OSHA officers shut down this excavation until we got a backhoe in and stepped back those straight banks. It's pretty safe. It's pretty safe to work under these less banks because it's very there's about 20 meters of lush standing straight up and down just to the right of this photograph. So it's not really unsafe, but they
Yeah.
they they shut us down for a day till we got a backhoe in there and stepped it back.
Yeah.
Fortunately, they didn't see that there was a drop off about 15 to 20 feet down to the water. That would have been impossible. But anyway, this site turned out to be 18,440 radiocarbon, or about 22,000 calendar years old. And again, based on elephant mammoth bone breakage and flaking, we were able to determine that this was an archaeological site. If you can go to the next slide, we can look at this bone bed. These are 1 square meters, 1 square meter excavated squares, And if you look where the circle is, that's a heavy concentration of small, spirally fractured bone fragments.
Okay.
And uh, within that, there is uh, an, uh, an anvil made of a mammoth vertebra it's broken in half and it's standing up on edge, and it has wear patterns all over the top of it. And right around that anvil is this concentration of spirally fractured bone. Once again, if you look at the color coding, you can see the green bones are the complete bones, and the only complete bones on the site are a few ribs and a few vertebra and one mammoth molar and one toe bone. So the lightest bones on the body, the ribs and the vertebra, the easiest bones to break by trampling. People say, well, other mammoths trampled on this and broke it up. Well, that's obviously not the case, because the ribs would have all been broken to smithereens long before you can break one of those big, thick limb bones by trampling.
Yeah.
So we can eliminate all the competing arguments. There's no geological process. This is the lowest energy geological formation in the world, wind blown less. So it's
Yeah.
not geology. It's not mammoths trampling on it. There's no evidence of big carnivores breaking the bones, and there's no big carnivore, not even the giant short-faced bear, that can break a full adult male mammoth limb bone at mid-shaft. They just can't do it. They could maybe chew on the end a little bit, but they can't break these bones at mid-shaft. Only humans with hammerstones can do that. So that's our argument, based on geological processes and what we can eliminate, what competing hypotheses we can eliminate. And so if you could just show the next slide. So there are two complete ribs, crossed ribs, and there's a little piece of spirally fractured limb bone underneath one of the ribs. And then on the right is the average size piece of spirally fractured, green fractured limb bone. And these mammoth femurs are about 4 feet long. And if you could go to the next slide, we can just quickly look at one of these mammoth femurs.
Yeah.
And the small arrows point to the impact points where the bone was hit with a hammerstone. And we can refit these. And it's interesting, both of the femurs show these impact points on the upper half of the femur. And the lower half of the femur, the bone is gone. And that's where the longest, thickest, heaviest bone exists, is in the lower half of those femurs. And we hypothesize that people took those away to make bone tools out of. Again, this is almost certainly not a kill site and butchering site. This is an old dead male mammoth, and they came along and just quarried the bone. It's a bone quarry as opposed to a stone quarry.
So, to be clear to those listening, this site, as we saw, dates, what do we say, about 18.5 thousand years ago. So, much, much more recent than Ceruti, but we see a similar type adaptation, which is extracting calories from the megafauna. So this as a survival adaptation for hominins had really been around for hundreds of thousands of years. What you're arguing, as a different, separate migration into the new world of modern Homo sapiens, or archaic Homo sapiens, I suppose, would have been that they came up through this mammoth steppe and then made their way into the Great Basin and Plains regions of North America.
Especially the Great Plains. Yeah, we see a lot of evidence of this kind of bone fracturing in the Great Plains in these sites that are, 15 to 35,000 years old.
But we still don't see a significant number of lithic tools, correct?
No, very few of these sites. There is a site in Oklahoma called the Burnham site that has some stone tools dated to about 35,000 years. It's been very, very controversial. And there's a couple of other finds. A mastodon site in Missouri that was made in kind of a salvage situation has dates of over 30,000 years old. And there were some big rocks found with it. And there was also one stone tool found with it. Unfortunately, that collection was lost in a fire when the University of Missouri collections facility burned down. But there's little bits and pieces here and there of evidence, but not very much. And
Do you think oh, sorry, go ahead.
part of the reason is archaeologists are trained not to look in this age of deposit, so they don't find it. That's probably the biggest reason we don't have more evidence.
Well, that's interesting. I mean, insofar as a sampling bias and this sort of interpretive framework that we approach the sites with, that is a fascinating issue and something I do want to talk to you about. But back to the sort of paucity of lithic or stone materials that are present at these sites. Again, it's I suppose you could say it's analogous to Cerutti, which is that they likely used bone and wood. They used materials that decompose and degrade, and that is why they're largely absent in the archaeological record. Is that also fair interpretation?
Yes, very much so, because if you get in the eastern United States where the soils are acidic, you don't get bone preserved at all. And of course, the wood doesn't preserve. And based on ethnographic evidence, a high percentage of the tools used by humans were not stone. They were wood, bone, plant materials, and so forth that just don't preserve. And probably more tools made of that material than were made from stone, really.
Yeah.
But the stone preserves and the others don't.
So who do you think these people were? The folks coming chasing the mammoth through the steppe?
I think these people were the ancestors of Clovis. I think their technology would have been very similar to Clovis people, and that really the only new thing kind of from an upper Paleolithic technology that Clovis people invented was the Clovis spear point, it appears to me. But based on the rest of the technology that we have from Clovis and upper Paleolithic cultures in the old world, they were very similar.
Are you an advocate of the Solutrean hypothesis?
I wouldn't say I'm an advocate, but I'm very open-minded about it. The more I've learned about human adaptations, the more I come to think that we ought to keep a real open mind about this. And I surely think that that Solutrean people could have got across along the ice front. I'll tell you a little anecdote. Dennis Stanford was giving a paper on the Solutrean hypothesis at one conference, and I got up and was giving a paper right after his. And I said, well, Dennis, if the Solutrean people got across, and I said, I think it's quite possible they did, the people that I'm studying were waiting on the shore, waiting for them with spears. So anyway, we always had kind of good-natured go back and forth on that. So yeah, I think it's quite possible. I'm not an advocate, but I think we ought to keep an open mind about it.
For some reason, my light is flashing in the background. So before I start having seizures, I'm going to unplug it. Hang on a second. Telling me I've been talking too long, apparently. Yeah, I mean, I think a great explanation for the rapid expansion of fluted point technology is I've always felt is there were already people here, and the technology spread among existing populations.
Yeah.
And that those populations may well have been relatively invisible archaeologically, and we see this in Asia a lot with certainly with early Homo there, where likely the broad use of bamboo had sort of with they didn't need to manipulate stone. They had terrific tools they could make from organics. It's very interesting. Well, just back up. So I'm 100% clear. What you would then are arguing is that the people coming across, they're Asiatic. They're the forebearers of modern Native American, both Northern and South American populations, and they're the folks who. Well, I guess on this I would ask too, because the genetics, and it's I'm not an expert on this by any stretch, and it's hard to even get into it. But there's these arguments of genetic variability coming as a result of a standstill in Beringia. I think your theory may answer that question without requiring the standstill. I don't know. What is there any relevance here?
Well, I think the fact that the Sandhills hypothesis suggests that there were people in Beringia maybe 20 or 30,000 years ago. Um, I think if those people were there, they would have come on to the south when the weather started changing, going into the last glacial maximum. So I think I don't think they stood still there. I think they came south through along the east side of the Rocky Mountains into the Great Plains. So I don't think all of them stood still there, but they went to warmer weather when the glacial climate started kicking in, maybe 27,000 years ago or so.
I have a hard time digesting the idea that they would have stood still for 15,000 years in Alaska. I mean,
No, not
it's
not a
it's a
good
nice
idea.
place, but
Not a good idea during the last glacial maximum.
right. So he struck me as a little bit of a tough pill to swallow.
But
The
I think the problem with some of these DNA studies is they use the current paradigm of the settling of the Americas, the timing of the settling of the Americas, to feed numbers into their genetic models. And if the archaeology isn't right, then their genetic model isn't right. So
yeah, they're looking for that. They're forcing the correlation.
right.
The in your theory, you've got this population coming in, and sort of expanding a bit about the American mid-continent. Do you see individuals who came in during this migration episode leaving the North America and expanding further?
Oh, well, I think they're probably certainly going as far as Central America and probably into South America also.
Okay.
I think these populations have been here long enough that they'd probably adapted to all of the different ecological niches in North and South America, pretty much.
Okay.
So,
Yeah. So it's a big migration, and
right.
they radiated basically everywhere. So
But
with
I don't.
sites like La Sena, you mentioned a couple of others, Burnham, Miami, Fry, and some of these others. That I think you coined the term of the American Paleolithic, which is very cool. I like that, and I think that might also, would you wrap CAPS technology, the Levallois, into the American Paleolithic? Or are we talking about something different?
Well, I think it would be the same time frame probably as the Cerruti Mastodon site. I don't think this is part of the mammoth step hypothesis, people. I think this is it's an earlier technology.
Oh,
And yeah,
okay.
yeah,
Well,
I,
that's interesting.
yeah, no,
So,
I think the mammoth step hypothesis suggests kind of a Clovis type of technology, these big game hunters, using bone tools, ivory tools, and very much like Clovis at this, say 30,000 years ago or so. Yeah.
okay.
Well, I think the cap technology is much older, and I think we're seeing it in a lot of places in North America, especially the deserts of the Great Basin in California.
Well, let's talk about that. Some folks who have watched Underground may have seen the Blaine Enser interview where we talked about CAPS technology, which is a Levallois type tool that was found in Blaine's interview. We mostly talk about his work in Alabama. He does talk about it being ubiquitous and that there's sites in the Northeast and on the West Coast and so forth. Um, we didn't really get much into the distribution of these sites, but you're seeing these materials in California. Can you elaborate a bit on that?
Yes, I would like to go back kind of just to a little bit of the history of this. There was a French archaeologist that taught at the University of Denver, and he did surveys all over the Great Plains and up into Wyoming. And he discovered back in the 1930s what's called the Black's Fork culture. And he recognized this as being very similar to Middle Paleolithic technology in the Old World, but it was all surface materials, kind of artifacts and lag gravels on high terraces, and he couldn't date it. So, I mean, you could say this looks like that, but you can't date it. And then many years later, at our conference in California, uh, Curtis Reynolds from Boston University, who works with Middle Paleolithic stuff in the Old World in Greece, especially a lot of Neanderthal stuff, he went back and reanalyzed this collection and wrote a chapter in our book. And he said the same thing. This stuff, looks like Middle Paleolithic technology from Europe, and but we can't date it. So the next step, and this technology also occurs in the other places in the Great Basin and in the deserts in Southern California, and it's all found on surface, high terraces, surfaces, and a lot of it is heavily patinated. Some of it has desert varnish on it, and so we're working with a team to try to learn more about these types of sites.
So Barbara Purdy worked at the container site not too far from here in Gainesville, and had come up with dates based on the patination of somewhere in the, I think she was going as far back as 50,000 years. Um, what I'm hearing from you, and I know that you've talked about Chris Ronalds and his work, and that there may be better dates now that push it considerably further back. If you're talking about it being consistent with Cerutti, then Barbara was a little young in her estimates.
Well, yeah, but we don't know how long this technology lasted. But yeah, I mean, she could be accurate also. I mean, if it lasted 50,000 years or whatever. But we think that some of this is quite early. It's amazing to see these sites in this desert pavement on these extremely high terraces in California, with the desert varnish on them. And desert varnish takes a long time to form, and heavy desert varnish. So yeah.
If there was a population that managed to survive for, I mean, we're talking about 80,000 years, from 100 and say 130 to 50,000 years ago, would we not see a more robust archaeological footprint?
Well, yeah, I think that's part of the problem is if you don't look, you don't find it. And I think the old saying, maybe it's just hiding in plain sight. Maybe, maybe people just haven't paid any attention to it. And they surely haven't paid any attention to these artifacts that are found on these desert pavements. They say, well, that's just Holocene uh, chipping debris from making stone tools of people leaving it behind. And it's just, and Curtis Reynolds went through this site at Black's Fork and used the old world tool typology and said, no, these are specific tool types that people made in the old world. It's not just quarry debris. So I think we need to take a closer look. The other thing I'd like to bring up here is it's possible that there was a human population that got into North America and became extinct. I think that would be a very interesting story in human evolution if they did not survive. I think that's within the realm of possibility.
Well, I mean, before you told me about the indigenous of South America having a potential Denisovan gene, then that's exactly what I was imagining would have happened. And I was thinking also possibly CAP technology could be explained by a Neanderthal or Neanderthal-like population that came and vanished. Um, I think the genetic story, we're just starting to scratch the surface. It starts to tell us otherwise. That would be even more mind-boggling. Um, to your point of looking, not perhaps looking at these sites appropriately, as you've just described with regards to um, the work that Runnels is doing. Uh, I know, and I've said this before on Underground, and have heard others say it. I think in many cases we're just not digging deep enough, and perhaps there was a period of relative archaeological invisibility. Maybe the population either did go extinct, or the numbers were reduced radically through some sort of a punctuated equilibrium type moment. Um, and we have these areas where we feel like it's it's going to be absent of archaeological material. But we're just, again, we just gotta get down below the hard pan. That may be the case. You've talked also about this idea that when the dates came back relative to some of these proboscidean sites you worked on, that they were immediately deemed too early to have been cultural sites, and so therefore ignored. And I know you have some horror stories, I think, that are, sort of fall within that category of experience. Share what you know on that front.
Well, I'll just use an example from California. There was a paleontological crew monitoring this excavation site, and the scraper hit a hearth. Now, this is all of us would recognize this as a hearth. It had some burned rock in it. It had reddened soil beneath the hearth, and it had charcoal in it. Well, there was also an archaeological monitor there, and the archaeological monitor said, "Well, this is too old to be an archaeological site." The paleontologist went ahead and ran a radiocarbon date on the charcoal, and it was older than 45,000 years. So this is now lost to science because archaeologists wouldn't pay any attention to it.
Yeah.
There's, I know of mammoth sites that paleontologists have found and that archaeologists wouldn't go work on because it was too old. But yet they the archaeologists just didn't want to work on it, and the paleontologists, the bones were all broken up, so they weren't as interested in it. They were back. The paleontologists many years ago were looking for sites with complete mammoth bones, and if the bones were broken all to smithereens, they didn't really care much about them. So,
My gosh,
these
yeah,
these things fall through the cracks all of the time. I mean, it happens probably every year that we don't even know about. And so,
yeah,
our archaeologists are trained to definitely don't look at anything over 20,000 years old. And most of the archaeology is done by CRM archaeologists who, a lot of people they got a master's degree fairly quickly and went out and got a job and are they don't recognize the kinds of things we're talking about. So
yeah, yeah. Yeah, well, I see that. My day job is CRM, and it's I see where things could be improved. I'll put it that way.
right.
So what is it that is, when you start talking about these early sites, 130,000 years, even 50,000 years, and there's this immediate, sort of pushback, it seems, from a big cross section of the establishment archaeological community. Why do you think that is? Why is it contentious?
Well, it all has to do with human ego. Number one, if you've been publishing something your whole career and you're a very established major professor in a major university, um, you never want to admit you're wrong. So that just happens, and that's the way it is. And there's kind of a group think thing, well, this is the way it is. This is what we know, and all of these other people are just, kind of radicals out there making claims on these early sites. And so it's kind of a culture that forms. We're the establishment culture, and we know the best, and anybody else that's kind of outside of that is not really accepted in. So it's a cultural thing, and it it almost, I mean, like the Clovis first thing almost gets to be, in my opinion, and I don't really want to insult people, but it almost gets to be like a religion. We know
Yeah,
this. We're never going to change, no matter what evidence you present us. So um, that that's the problem I think we have. I think people just need to open their minds, go out and look in older deposits, and I think you'll be surprised at what you find. But you also need to recognize you need to study old world lithic technology so that you understand that a lot of this stuff is not just quarry debris. You need to understand taphonomy, and you need to understand geology. You need to understand that certain geological situations are much better to study these bone sites in than others. So um,
yeah,
I think
yeah.
we need to
It's
do a
a
better job of educating our young archaeologists.
Well, I agree, and educating them also from an epistemological standpoint to remain open-minded. And, the more I do underground and start to look at what's going on in the old world or in South America, I'm beginning to recognize that, North American archaeologists, and sorry, the Canadians get lumped in with this too, and tend to have a narrow paradigm, and more so than in other parts of the world. And it's being recognized by our international colleagues, and it's a little embarrassing, but
Yes,
hopefully we can correct that.
the archaeologists in South America are doing archaeology every bit as well as we're doing up here. We can't look down our noses at them and say, well, they're South Americans and they can't, they aren't as good as we are or something, But they're doing excellent archaeology. And people coming in from France, like Eric Boeda, studying these sites in Brazil. He's an excellent lithic technologist, has written a textbook on lithic technology, and he knows a stone tool from something natural or something that a monkey might have made or something. You trust these people because the French are some of the best lithic technologists in the world.
Yeah.
You
Yeah.
don't.
Well, how have your colleagues reacted specifically to the Ceruti site?
Oh, well, as you know, there were some pretty harsh criticisms leveled against it. And actually, the editor of Nature said, "You know what you're up against," and he said, "This could damage your career, basically." Well, most of us were retired or at retirement age. Only a couple of younger archaeologists or geomorphologists involved in it. Um, so we knew what was coming, yeah, and we expected it. But it's interesting, and I'm sorry I didn't answer one of your questions very well earlier. But I'm going to go back to the critiques of the Cerruti site. You asked, what do you think the best critique of it is? And to tell you quite honestly, I don't see a good critique of the archaeo. I think it's got the complete package, It's got the correct geology, it's got the correct technology, it's got refitting, it's got use wear patterns on both bones and rocks. Um, it's got differential breakage of bones, only the heaviest bones are broken and the lightest bones aren't. It's got the whole package. It's better than any of these sites that I've excavated out in the Great Plains.
Yeah.
This has come as such a shock to my career that I cannot overestimate that. I mean,
Yeah.
I never thought there were humans here 100,000 years ago until I laid eyes on this site. But I'd done my background research on these sites in the Great Plains with broken mammoth bone, so I recognized it right away what it was. Except it was better; it had the big rocks there, which I don't have in the Great Plains, because
Yeah.
there aren't big rocks in the Great Plains. And the
Yeah.
reason we did the experiment in Africa with a hafted stone is we think people were carrying big rocks around hafted on a stick because there are not big rocks over this lush plain area out there. So they carried with them. So that's
Interesting.
part of the experiment.
Well, we keep hearing this mantra: extraordinary claims require extraordinary evidence, which I don't necessarily believe, but that's okay. But I would argue that Ceruti is pretty close to extraordinary evidence. There's not too many holes to punch in it based on the literature I've read. So it's incredible.
We knew that if we got a panel of archaeologists from the United States, that an article would be rejected. We asked for a panel of Paleolithic archaeologists in the Old World to examine this, that are used to seeing this kind of technology and don't have a dog in the fight over the early peopling of the Americas. And they didn't have any. Only one of the reviewers had a little bit of a problem with it. The others had no problem with it. It said, "Yeah, we've seen this stuff in the Old World. It's not anything new or different." So
Well,
that shows you some of the bias of even trying to get this stuff published.
well, to Nature's credit, they did publish it,
They did.
which I think says something. So here's a fun hypothetical for you. You have $15 million, or a benevolent billionaire says, "Look, I'm going to write you a check." Where do you go, and what are you looking for?
Well, we would continue. We're doing research in museum collections all over Western North America, looking at mammoth and mastodon bones for these type of fracture patterns. We're looking at paleontological collections. And so we would continue to do that and expand on it and go back then and re-excavate these sites if there's anything left of them where we see evidence of this type of fracture patterns. And it's interesting, we've looked at all of these, a lot of museum collections all over Canada, United States, Mexico, and these patterns don't seem to go back much earlier than this 130,000-year-old stuff. So that's kind of another piece of evidence. But we would continue to pursue that line of evidence. We would also continue to pursue and try to finance people that know more about lithic technology than I do on these sites in the desert pavements in the western United States and the sites in the eastern United States, like Ensor has commented on. So we would just go do a lot more field work because that's what it's going to take.
Yeah, do more of the same, and that's great. And your passion for this, certainly is apparent, and that's what it's going to take, I think, to advance this conversation is people who are willing to get out there and do the hard work, literally the hard work, go dig these sites, document them, break mastodon, femurs with hammers, and just continue on this course, which I think is really great science and very interesting. And I think our perspective 100 years from now, as it relates to the people into the New World, will be quite different than the establishment perspective, and probably a lot more aligned with what we heard from you today.
Well, I hope so. Too bad I won't be here to see it.
I'll talk to my grandkids. We'll be redeemed in posthumously. It's always better than nothing. So look, thank you for your time, Steve. This is really interesting. It's really opened my mind, and I've got all kinds of different directions I might go with this in the future on underground. So thank you for that. To folks listening, the Center for American Paleolithic Research, CAPR, website has a lot of very good, interesting, downloadable content, articles, and so forth. So I would encourage you to go to that website, quick Google search for the Center for American Paleolithic Research. Steve and his colleagues also have a new book. It's called, newish, published in 2022. It's called New Discoveries in the American Paleolithic. Again, that is New Discoveries in the American Paleolithic. We'll put up an image of the book for you to see. And that is Sunbelt Publications out of California. And it's going to have some fascinating articles in there along these lines. So just folks listening, I would encourage you, if you're an archaeologist, open your mind to some of these possibilities, read the literature, get connected to it. There's a lot to be learned here. And we all should be educated on this. It frankly should be, there should be a whole course here on the American Paleolithic that's taught as a standard practice in graduate programs, in my opinion, because this is real. Spread the word, and stay tuned for the next episode of Underground. Steve, thank you so very much. I appreciate it.
And thank you for having me on. I enjoyed it, and keep up the good work.
You got it. Thank you. Okay. See you, everybody.